So this is the homework. That's the good news because we want to do it together. It is 10:19, okay? So in algebra, we learned that an exponent to an exponent, you multiply the exponents. We multiply the exponents. So we're going to get a 7 to the 2/4, which is the same thing as 7 to the 1/2. That's all. So I multiplied exponents, and then I reduced it. I'm going to multiply the exponents. 3 times 1/2 is 3/2. There's nothing to reduce. I'm going to leave it like that. Am I going slowly enough? No, number 3, there's an invisible 1 right here. We normally don't write, but I want to write it. There's normally an invisible 1 right there. And when we do exponents, when we were in algebra, we subtracted. When we divided, we subtracted exponents. When we divided in algebra, we subtract exponents. So we've got a 5 to the 1/5 subtract 1. And that's just negative 4/5. Right? Negative 4/5. 1/5 minus 1 is a negative 4/5. Okay? That's all we're doing is manipulating exponents. We've got to have a 5 to the negative 4/5. How am I doing? 10. Number 4, 10 has an exponent also. It's an invisible 1. When I divide, I subtract exponents. 10 to the 1, subtract 1/4. When I divide, I subtract exponents. 1 subtract 1/4 is 3/4. I've got a 10 to the 3/4. That's all I'm going to do. Five, we're going to multiply exponents because I've got an exponent to an exponent. Multiply exponents, but to both of them. So multiply that. 5 times a negative 1/5 is a negative 1. And I'm going to multiply exponents here. Multiply exponents here. 5 times a negative 1/5 is a negative 1. Now, Braden, this is going to answer a question you had. When you have negative exponents that are in the wrong place, this one has to come up to make it positive. This one has to come down to make it positive. So we're going to switch places, make it a 9 to the positive 1, and a 6 to the positive. That's how we eliminate the negative exponent. Negative exponents are in the wrong place. So if they're on the bottom, we bring it up, 9 to the 1. If it's on the top, we bring it down, 6 to the 1. And of course, 9 divided by 6 is just 1.5. That's a simpler answer, okay? So we'll do the same thing with the negative 1. We're going to multiply it to both of these. Okay? So we'll do the first one first. We'll go 7. Negative 3/4 times negative 1 is a positive 3/4. 7 1/4 times negative 1 is a 7 to the negative 1/4. So I just multiplied exponents. Now we also learned in algebra that when you multiply the same bases, you add exponents. You add exponents, okay? So we're going to add. 3/4 plus a negative 1/4 is a 2/4. 2/4, right? So we're going to have a 7 to the 2/4, which is to the 1/2. That's right. 7 to the 2/4. Luke, you're right. That's the same as 7 to the 1/2 power, okay? Now, these are a little bit of what I was teaching with our warm-up, okay? So if I multiply 3 times 75, I don't know, I think it's 150. let's see, 3 times 75, I think it's 150. It's 225. It's the square root of 225, okay? Now, is there a square root of 225? What times what makes 225? It might be a perfect square root. Something times something. I think it is.
15.
It is 15. It's exactly 15. There's no leftovers. Square root of 225 is 15. Yep. Okay. Okay, we'll multiply these. 81 times 9. 81 times 9. Whoops, times 9. I get 729. To the third power. Great question. Really good question. So it's cube root stays cube root. Really good question. Now, is there, what is it?
27.
Is it 27? We can check it. I believe you. I'm just going to check it. No, 27 is too big. But in my calculator, I think I have it.
Oh, I know what it is.
It's 9.
It's not.
9 times 9 times 9. Or 9 to the third power, right? All right. Okay, multiply these two. What is 12 times 8?
96.
96. Now, is there a fourth root of 96? I don't think so. I don't think so. But 96 divided by 16. Okay. Okay, I want you to look at what I wrote.
That's what I said.
You were right.
Telling you.
You were right. I'm going to show them why. You like that, don't you? 16 times 6. I chose 16 on purpose because what times what times what times what makes 16?
4.
2. This is a perfect, that's a perfect,
Oh.
that's a perfect one, right? So I can eliminate this and put 2, can't I?
Yeah.
I'm stuck with this, can't do anything with it, but I can make that a 2, I know 2, okay? Right? So I can make this 2, and then leave the fourth root of 6, because the fourth root of 6 is really a bad number. I'll show you real quick. Fourth root of 6. Ugly decimals, so I'm going to leave it as fourth root of 6, okay? All right, now, 10. Here for 10? Let's multiply it. Fourth root of, what's 9 times 1? 9 is 81. I think that's a perfect fourth root. I think it is. What times what times what times what makes 81? Or you can use your phone, your calculator, but what times what times what times what makes 81? 3 times 3 is 9 times 3 is 27 times 3 is? So yeah, that's what you said.
So that's 3.
Three.
It is 3.
3.
3. C. So fourth root of 81 is just 3. Now, before we do this, we're going to divide. 128 divided by 4. I don't know what it is. 32. So I just divided. That's all I did. Okay? Is there a fifth root of 32? What times what times what times what times what?
2.
2 is right. So it's just 2, isn't it?
Yeah.
You guys getting it?
Yeah.
The next one's 4.
It's going to be 1/4, but you got the right idea. Alonzo, you're way ahead of me. So if I divide this, the 5 is on top. It reduces to 1/16, but I still have to do a square root, okay?
That's literally 2. I mean, that's 4.
Yes. So 5 over 80 as a fraction reduces to 1/16. You get that? 5 over 80 is 1/16, right? And that's going to be 1, and that's going to be 4, right? So 1/4. Okay, turn the back over, and we can go outside and work on the back if you guys want to go outside and work on the back. Okay?
Oh, yeah, I was thinking,
Why you excluding?